Okay, in this video, we're going to do the 2.8 notes. Now, you did a lot of 2.8 last year in Algebra 2, so this should be a refresher. And as you go through it, remember where you may have struggled in Algebra 2 so that you nail it this time. Okay, so identify one-to-one functions. How do we know we have a one-to-one function? Okay, we have a one-to-one function when 1x corresponds to 1y, and 1y also corresponds to 1x. Okay, so each input yields one unique output. Okay, so if you have a function, so I'm going to say if you have a function, an FCN is function, it passes what test? The vertical line test. Okay, the VLT, okay? Then I'm going to say, if that function passes the horizontal line test, and that's the HLT, then that function has an inverse that is a function. So basically, if you have a function like this, let's just do something very basic. So let's do the parent function for the line. Okay, that's your line. That's your y equals x. So this is my function is, it equals x, okay? So y equals x. Okay, does this pass the horizontal line test? So if you drew horizontal lines, does it only hit every place once? Yes. I know it had to pass the vertical line test. See here my vertical lines, because that's a parent function. It's not a parent relation. So therefore, it already passes the vertical line test. So the line is an example of a one-to-one function. So if it passes both, so if you pass the vertical line test and the horizontal line test, then you are a one-to-one function. Okay? So let's look at other functions. Okay, look at this first one. That's a cubic. All right, look what's going to happen if you try to do a horizontal line test. So you're hitting 3 places. So this fails the horizontal line test. So this is not one-to-one. Okay, let's do the next one. Okay, so one comment about this next one, which can be a little bit misleading. This section right here is not flat. So therefore, when you draw your horizontal lines, you actually don't hit multiple places. Okay, so I just need to point that out. If you would zoom in, you'd see that on a graphing calculator. So this passes both tests, vertical and horizontal. So this is one-to-one. So this is one-to-one. Okay, look at this next one. Is this a function? No, because it fails the vertical line test right off the bat. So this is not a function, and it's certainly not one-to-one. Okay, let's keep going. Okay, look at this next one. And again, I'm going to have a commentary on this. This is a function. This is not vertical. Okay, so I'm just going to tell you that that's not vertical. Okay, so when I try to do my tests on it, here comes my vertical line tests. We're okay, especially since that section is not vertical. What about the horizontal line test? That's going to be okay. I'm only hitting one place. So this is 1-to-1. Okay, look at this next one. The second I try to do a horizontal line test, look what's going to happen. I'm going to hit multiple places. So this is not 1-to-1. And look at this. This last one is not a function because it fails the vertical line test. So therefore, it's not 1-to-1. So out of these 6 examples, you only have 2. This one right here and this one that are 1-to-1. Okay, so you need to be able to graph or give me a sketch of a 1-to-1 or give me a sketch of a function that's not 1-to-1. So be comfortable doing that. All right, next thing. Inverse functions and ordered pairs. So I'm going to write out an explanation about that. So we're going to say that the inverse, so the inverse of a relation of the ordered pairs xy is yx. So you're just going to flip it. So that means that your domain of your f of x function becomes the range of the inverse. And the range of your f of x function becomes the domain of the inverse. So let's explain this explicitly. Okay, so these are discrete. This is a discrete function, f of x. Oh, and one notation point. That means inverse. Okay, when you raise the function to the -1, that's your tip-off. I'm talking about inverse. Okay, discrete functions only have coordinate pairs. The x values are the domain. So I have 2, I have 6, I have 5, and I have 10. I'm going to use set notation, so I use these little curlicues. My range are the y's. So 3, 8, 9, and 4. Okay. I'm now looking for the inverse. So remember I said the range of your function becomes the domain of the inverse. So I'm going to just copy this and put it right there. Okay, same idea. Okay, so let me get rid of that line. Okay, what about the domain of the original? Isn't that going to become the range of the inverse? And yes, it is. There you have it. Okay, so let me switch to brown here. That goes here. Okay, so don't even think about it. Just switch it up. Okay, so notation, f to the -1 of x denotes the inverse. Okay, it does not mean 1 over f of x. Okay, so just make sure you understand that. So what's the link between inverses and 1-to-1 functions? A 1-to-1 function is a function that has an inverse that is also a function. Okay? All right. So I'm going to ask you to do this. We have our quiz. You need to be able to switch the domain and the ranges. appropriately, then I'm going to give you some random function. And you're going to need to graph the inverse. Well, how on earth did you do that? Well, it's all based on switching the x and the y's. It's also a fact that your inverse is a reflection over this line y equals x. So what I would suggest that you do, get the corner points. Okay, here's your corner points. This other value right here, where it crosses, that I call a hinge. That's going to be in common to both functions. I want to get the inverse. So I'm going to first go and I'm going to tell myself my points. So I have 1, 2, 3, 4. This is 4, comma, and then counting up 1, 2, 3, 4, 5, 6. So 4, 6 is my function point. 6, 4 is my inverse point. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Okay, there it is. That's the point. 6, comma 4. That's the inverse of 4, comma 6. Okay, go to the next one. This is going to be negative 2, comma 1, 2, 3. So therefore 3, comma negative 2, 1, 2, 3, 1, 2 is going to be my inverse point. Oh, what did I do incorrectly? Hopefully you're yelling at me that I plotted this one in a crazy manner. I went down 4, I need to go up 4. I knew that looked funny. Okay, so let me try it again. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Much better. So this is 6, comma 4. Okay, next one. The hinge is staying. This green dot is going to be 1, 2, 3, 4, 5. So that is negative 5, negative 6. This is negative 5, negative 6. So, and I should make that. So let me change colors there. Just be consistent. I'm going to make that negative 5, negative 6. So I want negative 6, negative 5 for my other point. Okay, so this is negative 6, negative 5. Right there, that is negative 6, comma, negative 5. Okay, now connect the dots. This is going to connect to that. I'm going to go through my hinge to connect the other one. That is f to the negative 1 of x. And this is easy as that. So what kinds of things do you see? So you want to look at some patterns. Does it look like I flipped over the line y equals x? Or better stated, that I reflected over the line y equals x? Okay, so notice how these points between the inverses and the regular function are related. So I would not tell you to draw these in, but do you see how there is a straight line connecting these? And when it crosses that line, a right angle is formed. So that's just things to note. Don't draw those in. So I'm actually going to get rid of them. But note that you have that relationship so that you can verify the points that you selected were correct. So let me just roll those out. Okay, so that's what your inverse looks like that. Okay, now they ask you to evaluate it. So neat things are going to happen. So the first one they say, tell me what f of 0 is. So that's the original function. So if my x is 0, I'm going to count up to here, right? So that's 1, 2, 3, 4. That's going to be 4. Now the next one is, they want to know what is f to the negative 1 of 3. So that means I'm going to evaluate it where the blue function is 3, and I can see that's going to be negative 2. Okay? So know how you're going to handle that. So f to the negative 1 of 3 is negative 2. Okay, let's continue to the next one. So other things I'm gonna point out before I move on. So this is your x. This is your y of the f of x, right? So this is your x of the inverse function, but wasn't it previously the y of your original function? And if you know that, then I could have used this point to get the negative 2 just as well. Okay, so just think about that. All right, let's do the next one. I want to find g to the negative 1. So I'm going to pick these points, and I'm going to flip those or reflect them over the line y equals x. Okay, so first get your coordinate pairs. So this first brown one is negative 3 comma negative 2. The next one is 0 comma 1. And this last one is 6 comma 5. So you're going to flip those, right? So negative 3, negative 2. I now want negative 2, negative 3. 1, 2, 3. Do you see how that vertical line can pass right through there? So this is negative 2 comma negative 3. Then 0, 1 is going to become 1, 0, which is right there. So this is 1 comma 0. And 6, 5 is going to become 5, 6, which is right here. So this is 5 comma 6. Once I have them, I'm going to connect. Oh, and this is the hinge right here. Let's connect, and let's go through the hinge to the next point. And there you have it. That's my inverse. So now I'm going to answer these questions. G of 3. So if I have 3, I'm looking on the brown function or the dark function. 1, 2, 3. Go up, and it looks like it's also going to be 1, 2, 3. So that's going to be 3. This is pretty much the hinge, right? Look what's going to happen here. Because that's the hinge, I'm going to have the same value right there. And then what about g to the negative 1 of negative 2? So negative 2 is here. That's going to be a negative 3. Okay? So this point here was the hinge, and that's why they're both the same. Okay, so I'm going to have you graph these. So we have some strategies for graphing. Okay? Then we have these inverse tables. Okay, so the functions g, h, and k are defined by the following tables. Okay, so here is your g of x, right there, your h of x, and your k of x. Here are all the values. For each function, decide if it's 1 to 1, why or why not. Okay, look at g of x. To be 1 to 1, you have to pass the vertical line test and the horizontal line test. Okay, the vertical line test happens over here. Anything repeats? So I have no repeats, so I'm good to go. Here is your horizontal line test. Do I have any repeats? No repeats. Good to go. Okay, so this is yes, it is. And I have no repeats of x or g of x. Okay, go on to the next one. I look for the vertical line test. Do I have any repeats here? And there are no repeats, so I'm okay there. So this is a function. Does this function have an inverse? That's a function. So let's look. Uh-oh, I have repeats. Okay, so the horizontal line test is failed. So this is no, because we failed the horizontal line test. Okay, next one. I'm looking, And this is, remember, the vertical line test. Is this a function? Any repeats? No repeats. So I'm okay there. What about the horizontal line test? I have any repeats? Nope. No repeats. So I'm okay there. Okay, so I can say right here, this is a...
I'm not sure I understand. Is there something else I can help with?
Nope. So let me get you out. Okay, so I'm going to say, no. Thank you, Siri.
No problem.
Okay, so is this one-to-one the last one? And it was yes. And because I had no repeats of x, or what was that one? That was k of x. Okay, so now it says for each function above, make a table of values for the inverse and then decide if the inverse represents a function. Okay, so you're going to switch these two columns. Okay, so I want to know if the inverse is a function. Okay, so let's do switchy. Negative 2.5, 0, 2.5, 5, 7.5. Okay, so what's the y value of the g negative 1 function is going to be the x's from the original function, 5, 10, 15. That's good. Okay, let's do the other one. This is 15, 6, negative 1, 6, 15. Remember, this was our problem child. It's still a problem because now it shows that this is not a function, which is what we knew when we analyzed it the first time around. And then the last one, this is going to be negative 1, 0, 1, 2, and 3. 1/3, 1, 3, 9, 27. So based on our previous explanation, we can say that this is not a function. And how come? Because you are repeating your x's. You fail. In this situation, you're going to fail the vertical line test. Okay, so now they want us to evaluate some things. So let's look carefully at what they're asking for. Okay, g of 5. Go back up here. When x is 5, g of 5 is 2.5. Okay, g negative 1 of 5. So that x is 5. That's going to be 10. H of negative 1, come up here. Negative 1 gives me 6. Okay, k of 3. 3 gives me 1. And k negative 1 of 3. So that's going to give me 27. So make sure you can get those values by reading the table. Oh, now let's try some compositions. So how do we do that? Well, you're going to work on the inside first. What is g of g to the negative 1 of 5? So here's my g function. When I have a 5 for my x, I get a 10 out. So now I'm looking for g of 10. Come up here. What's g of 10? I should be getting 5 back, and I do. So think about that. Okay, let's do the same thing over here. Inside, figure out this first. What's g of 5? Come up here. G of 5 is 2.5. Okay, so this is going to be 2.5. And so now I'm looking for g to the negative 1 of 2.5. So come down here, and g to the negative 1 of 2.5 is 5. So I do get that 5 back. Okay, so think about that because these are nice relationships. Be able to read these tables comfortably and to create the table if I give you the original functions table. Be able to create the inverse function table. Okay, so now I want to find an inverse. If my original function is a line that looks like this, What's my inverse? Here are the steps. Step 1, change out of function notation. What does that mean? It means if you have it written as f of x, make it y equals instead. Okay, that's first step. Second step, switch places, and I just spelled switch incorrectly, so hold on. Switch places for x and y. And that literally means just that. My y was first, my x is now first. Okay, next step. Solve for y. Okay, so that means I'm going to move things around. X minus 5 will equal 2y. Divide by 2, divide by 2. So y equals x minus 5 over 2. Okay, step 4. Put back in function notation. Okay, what does that mean? That means that that y is not really y, but it's f to the negative 1 of x, and that equals the inverse. Oops, minus 5. Okay, those are your steps. So the inverse function notation now is going to be f to the negative 1 of x equals x minus 5 over 2. Okay, so when I asked you to find the inverse algebraically, this is what I want, and I want to see those 4 steps. So let's try to find some other ones. So I'm going to go through and do it. You should try to do it before I get it done, so you should probably stop the video. But I'm going to, I guess I'm going to label them with numbers. Okay, so here's my first step. Here's my second step. Okay, my third step is to solve. Oh gosh, how am I going to do that? I have to unlock the square root. So why don't you square both sides? That'll do it. Then now I'm going to have to solve, right? So it's going to be, let's see, y is going to equal 2 minus x squared. So put it back in function notation, and I get f to the negative 1 of x equals 2 minus x squared, and we're donesies. Okay, so I'm doing this quickly. You don't have to do it quickly. You can think it through slowly so that you understand it. Okay, my first step, y equals 2x plus 3 over 5. My second step, switch. My third step, I have to solve for the new y. So I'm going to do my cross products. 5x equals 2y plus 3. PEMDAS tells me to do the subtraction first and then do the division. So my new function, my inverse, is going, and this I should have, let me go back. Since my function was initially the g of x, I'm going to do the g of negative 1 of x, and that is just 5x minus 3 over 2. Okay, here's another example. So here I go. Y equals x cubed minus 1. X equals y cubed minus 1. Okay, x plus 1 equals y cubed. But I want to get just plain old y. So take the cube root of both sides, and you can isolate the y like that. So this is 4, and that's going to be m to the negative 1 of x equals the cubed root of x plus 1. And that is the inverse function. Okay, last one. So we have y equals the cubed root of x plus 4 over 5. Switch. X equals the cubed root of y plus 4 over 5. Okay, so I had to solve now. So let's be clever algebraically. 5x equals the cubed root of y plus 4. Subtract 4 from both sides, and you get this. Okay, now cube both. 5x minus 4 in parentheses cubed equals, when you cube a cube root, you free it up. Okay, and then the last step is going to be n to the negative 1 of x equals 5x minus 4, and that whole thing is cubed. Okay, so this is algebraic examples, how you work through and find the inverse. Okay, we have one more major thing to talk about, and that is going to be verifying you have inverse by composition. Okay, so the textbook, we want you to read the textbook, they call this the inverse function property. Okay, so in order to know that you have inverses, you have to do this. F of f to the negative 1 of x has to equal f to the negative 1 of f of x, and they both have to equal x. So you have to test both of them. Go this way, you should get x. Okay, so here's some examples. They've given me both functions, okay? And they want to say, see if they're inverses of each other. So I'm not going to do it algebraically. I'm going to use this composition rule. So my first thing is going to be, because I have f of x and g of x, I'm going to find f of g of x. What's that going to be? Well, remember how you do a composition. Since f came first, start with that f function. Wherever you have an x, you're going to put in the entire g of x function. Okay, what happens next? The 2's can cancel, right? These 2's can cancel. So that's going to give me the square root of x squared, and that's going to equal x. So that's good. That's what I want it to equal. Now go the other way. Now I'm going to do g of f of x. Start out with your g function. It wants me to write down an x. Instead of writing down the x, I'm going to write down radical x plus 2, and then they want me to square that. Minus 2. Okay, if you square a square root, what happens is you release it. Okay, so those 2's are going to cancel, and I'm left with x, which is what I want. So I have now proved that they are indeed inverses of each other. So what about the domain and range? Well, look at that domain of that parent function f of x. What is that? Remember, this is going to look like what? You've got to remember from your transformations. So I'm going to go to the left 2. So that's going to be negative 2, and this is going to go like that. What's that domain going to be? It's going to be negative 2 to infinity. Okay, so that's the domain of f of x. That's also going to be the range of g of x. What about the range of f of x? That's going to go from 0 to infinity, which is also the domain of the inverse function. So I'm switching these up, right? So that's what you have to know. So you have to still have in play all your information about transformations that we did in 2.6. So this is from 2.6, okay? All right, so we're going to do just one more, and then we're going to call it a day. Okay, so I have to do the compositions because they want me to verify that they're indeed inverses. Okay, so I'm going to do the first one. This is going to be m of n of x. So that means that you start out with the m function, The second you hit the x, you're going to put in its place the cubed root of x plus 2 over 3. Okay, and then you're going to continue. Minus 2, and then this whole thing is cubed. Okay, now let's start canceling things out. This can cancel this. What's that going to give me? That's going to give me radical x cubed plus 2 minus 2, and that whole thing is going to be cubed. These can cancel, and then if I take the cube of a cube root, they cancel. That gives me the x, and I'm happy. Okay, let's go the other way. Now I want to do n of m of x. Start out with the n function. I have a cubed root, but the second I try to write the x, I'm going to instead write in the other function, and that's going to be cubed, right? And then plus 2 over 3. So what happens next? So if I deal with that cubing of a cube root, that's going to release that piece of it, right? So I now have 3x minus 2 plus 2 over 3. What happens next is these 2's will cancel themselves out. That is going to leave me with 3x over 3. Now the 3's will cancel, and I am going to get x. That's what I wanted. I have verified that they are inverses. Okay, domain and range. Look what you have. You have a parabola. So that parabola is going to be stretched and moved over. Okay, so where is it going to be moved over to? It's going to be moved over to the right here and stretched up. Okay, so that's what that looks like. This is what m of n looks like. And you need to still know that stuff. So what's the domain? Well, the domain of any parabola is always negative infinity to infinity. That's the domain of m of x, and that is the range of n of x. What about the range of m of x? So you're going to start where? So think about that. Where are you starting? If you moved over to the right 2, then you are going to start at an x value of 0 and go to infinity. That's going to be also your domain of the inverse function, 0 to infinity. Okay, and there we have it. So that completes this lesson. So your job is to do a good job on the homework so that you can understand all the main features of this. Okay, so let's do a very quick recap. You will need to be able to recognize one-to-one functions graphically, explain why they are one-to-one or why they are not. Remember, they have to pass both the vertical line test and the horizontal line test. You have to be able to establish domain and range and know to flip them for the inverse. You have to be able to draw an inverse given the original function, and knowing it flips over the line y equals x, and knowing that you're going to reverse your coordinate pairs. You have to be able to evaluate any function I give you. You need to be able to look at tables and know whether you have vertical line test passage and horizontal line test passage. You need both to have it be one-to-one. If I give you the original functions, you have to be able to give me the table of the inverse and evaluate that as well. You have to be able to find the inverse through algebra using these 4 steps that I went over in great detail. You have to be able to do the inverse function property, which means using composition 2 times, right? G of x, and G of f of x, they both have to equal x. You have to do both of them, and you should be able to remember domain and range of the function from 2.6. Okay, so the homework for this section is up here. So here are the problems. When you get to 49, 53, and 55, they say prove by algebra only. They ask you to do compositions to check. We don't need you to do that. Okay, so you want you to practice getting the inverses by algebra and then practice proving you have them by composition. Okay, so notice that we've given you all of the odd problems. That's because we want you to check your answers in the back of the textbook. So you have to use your textbook. Okay, we're trying to get you into reading it. That's why for every one of these, we're saying read this section. See what they're saying to you. Read this section, and so on. Okay, so I hope this helped. And good luck on your future math classes.